All right, we're using finite geometric series here. And let's go ahead and read the problem. We're asked to find what? The sum of the first 25 terms in this geometric series. And then they give it to us there as the first 3 terms. All right, so when we're doing these, it's always good to rewrite our formula. So for a geometric series, the formula is S of n for the sum of the first n terms is equal to a sub 1, or the first term, 1 minus r, or the common ratio, to the power of n, the number of terms, divided by 1 minus r, the common ratio. All right, so we'll just go ahead and plug these in, and that should be all we need. So find the sum of the first 25 terms. So 25 is in this geometric series, yep. So find the sum. They want S of n, or in this case, S of 25. Start using 25 for our n, and then they give us some first terms here. All right, so let's go ahead and find the common ratio. The common ratio is going to be the second divided by the first. And remember, you can go anywhere in the order here, but let's go ahead and just do second and first. So that's 6 divided by 8, 2 over 4. 3 goes, no, 3 over 4. 2 goes into 6 3 times, 2 goes into 8 4 times. Check, 3 over 4. All right, let's go ahead and plug all that into our formula now. And then here's our a sub 1 also. First term, always the first term. So S of 25, the sum of the first 25 terms, is equal to 8 times 1 minus 3/4 to the n all over 1 minus 3/4. Okay, got to do some simplifying here. And 8 times 1 minus 3/4. Oh, that's not an n. That's a 25. All right. 1 minus 3/4 to the 25th power. Get my calculator out. I might need a calculator. Yep, that's right. So 3/4 to the 25th. Oh, wow. Really big number. Let's see. How do I want to do this then? Well, this is the same thing as 3 to the 25 over 4 to the 25. All over, and let's take care of that. That's 1/4 left. Okay. This would flip and multiply, so that's really a 32, but we can worry about that in a little bit. Let's get this out of the way. All right. And 3 to the 25. Let's see if my calculator let me do that. Oh, it's a really big number. All right. Let's see. Options. 0.75 to the 25. Now, let's go ahead and, so my calculator for this, let's do some side work up here, some side work. So 3 over 4, or 0.75 to the 25, my calculator gives me 7.5254345 ... in scientific notation times 10 to the negative 4. Okay, so it's a negative 4. Come on. Why won't it let me write? Gee, come on. All right, there we go. Well, all right. So what this means is this is a scientific notation. This number is getting smaller. -4, negative exponent, smaller. So which way would I bounce the decimal to make the number smaller? All right, well, I'd bounce it to the left here. So I always do that. I don't really remember the rules other than this is smaller, and if it's positive, it's bigger. So it's 4 times 4 bounces. 1, 2, 3, 4. So this is my new spot for the decimal, and each one of these cradles has a 0. All right, so this now becomes 0.000755 ... All right, I don't know if that's going to help or hurt. So let's see. So I'll take that. 1 minus that answer. So 1 minus this answer. 1 minus answer. All right, so I actually got a number here now, so that's a little bit better. So that's good. So all of this was times 8. And when you're dividing by 1/4, it flips it and multiplies. So all of this is times 32. All right. So in my calculator, I take this answer and times 32. So the answer was 0.99924 ... Remember the old rule, never round it until your final answer. So times 32. And I get 31.975 ... All right, and we'll choose one of the answers. And there it is right there. Looks like they rounded to 2 decimal places. So it'd been nice if they just said that. Find the sum of the first 25 terms. Okay, that's fine. All right, so going through the process here. So we got a little bit stuck on how big this got on the calculator. So just try some different strategies, see if any of those work to kind of help. So the thing that I noticed though was that if I just 1 minus this crazy answer gave me something that wasn't so crazy. All right, next one. The geometric sequence a sub I is defined by the formula. Okay, so this is the a sub I. Oh, it's a sequence. Okay, find the sum. All right, so now they're changing it to a series. Find the sum of the first 20 terms in the sequence. All right, so they're just kind of throwing some vocabulary around on us. All right, so here's our first term, a sub 1. So write our formula. S of n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. Plug in what we know. All right, so this is our common ratio right here. When it's in recursive format, there it is. There's our a sub 1 term. They marked it as a sub 1. That's nice. And then how many are we looking at? There's our n. All right, so plug everything in. The sum of the first 20 terms is equal to 8 times a sub 1 is 8. 1 minus r is negative 1.5. Notice how I put this in parentheses. It's a negative 1.5. That's our common ratio, so we have to preserve it. It's to the 20. And all over 1 minus our common ratio, negative 1.5. So we always want to use kind of parentheses when we have that extra negative floating around. And let's go from there. So this is equal to 8, 1. I can't change this to a plus sign. Remember, exponents come first. So negative, so that's just going to turn it into a positive because this is an even exponent. 1.5 exponent key 20. All right. So that's minus, and that's this minus sign right here, minus. This minus sign went away because as an even power, 1.5 to the 20 is 3325.25673. Stop. And 1 plus 1.5 is 2.5. Negative and a negative make a positive, and we can add 1 plus 1.5, hopefully. All right, so then we subtract these, multiply by 8, divide by 2.5. All right, so, all right, 1 minus answer, check. So now we got a big negative number times 8, and then divided by 2.5. Final solution, negative 10637.62154, and that's the complete answer. Uh, 10637.621. Once again, they're rounding again without telling us. It'd be really nice if they told us if they're rounding, but fine.